This is Unit 4, Day 1. Unit 4 is about function transformation. So if you guys remember last year in geometry, or even as far back to algebra, or even 8th grade, we learned how to shift functions. So we're going to be moving them only left, right, and up and down today. So we're doing vertical and horizontal shifts today. All right, example 1 here. Actually, I should probably start before that. The basic geometric transformations, so you learned these last year. We're translating, which is the shifting, left, right, up, and down. Reflecting, rotating, and dilating can all be done to the graphs of the functions by algebraically manipulating them. Rotating functions is out of the scope of our work in this course, so we're not going to be touching those. But we will investigate the others, all of which you originally saw in Common Core Algebra 1. Right now, let's concentrate on shifting functions. All right, so example 1 gives you the absolute value of x. So it says without the use of your calculator, graph that. Well, guys, if you're struggling to know what the graph of y equals absolute value of x looks like, just make a little t-chart. So you're going to pick a couple negative values for the x, so -3, -2, -1, 0, 1, 2, 3. So those are my x values. And then just input them in the function. So the function is the absolute value of x. So if you plug in -3, the absolute value of -3 is +3. Absolute value of -2 is +2, 1, 0, 1, 2, 3. And if you ever remember, we used to teach you value is the v, so it's going to make a v. So 0, 0, 1, 1, 2, 2, 3, 3, and so forth. -1, 1, -2, 2, -3, 3. So here's that function, y equals the absolute value of x. Okay? Part B, use your calculator to generate a table of values, graph the other two absolute value functions. Well, looking back here, you're just going to put them in the graphing calculator and graph them. So the first one here, absolute value of x minus 3, and then come outside the absolute value plus 2. And I'm going to do that in a different color just so you can see where I am. And you get this graph right here that I have in red. So that is the absolute value of x minus 3, close the absolute value plus 2. All right, my last one is absolute value of x plus 1, close the absolute value, minus 4. So that is going to be down here like this. So hopefully, by using your graphing calculator, you can tell which way, let me just label this over here. You could tell which way that the graphs are shifting here and notice some of its properties. It says, how would the graph of y equals absolute value of x be shifted in order to produce this graph? All right. Whatever is inside the absolute values, or sometimes it's parentheses if you're doing quadratic, is always the opposite way. So normally you're going to think -6 would mean left 6, but it means right 6. And then the y value is always what it is, so that would mean down 8. Okay, so whatever's inside the absolute value, or inside the square root, or inside the set of parentheses, it's always going to be the opposite, and that's your shift on x. That's moving left and right in the opposite direction. But whatever's on the outside is the shift vertically on your y, and that is what it is. So if it's negative, you move down. If it's positive, you move up. All right, so we're just kind of talking about this here. So again, this is your shift on y. So that's your up and down, okay, that's on your y, and that moves what it is. The one that's always inside moves it left or right, and it's always the opposite direction, okay? Example 2. The function f of x is shown on the grid below. A second function g is defined by. Okay, so now you guys are going to look at this right here, and you're going to say, okay, what does that mean I shift? Well, the inside is opposite, so that means I'm moving right 3, up 1. So I go to my graph and I'm going to pick definite points. So this is a nice easy point right there. So I'm going to move it right 3 up 1, put a new point. Same thing down here. I'm going to move this right 3, up 1. Here's my point. And there's that already. Okay? Now, you can do the same thing for the next points on the graph. Okay, the next one shows up here. So move it right 3, up 1. And the same thing here. Right 3, up 1. And there's the shift of that graph. So anything that was in black is your f of x function that was already given to you. And what I just shifted in blue is my g of x function. Part B says, using the definition of g, what is the value of g of x? Well, look, guys. They're asking you, where is x 0 on the g function? So I come to the graph. Here's where x is 0. I come up, and on my g graph, it has a value of 2. So g of 0 is 2. And don't forget, that's like the coordinate 0, 2 on the g graph. Identify how the graph of f has been transformed to produce the graph of it and sketch it on the grid. Well, I kind of jumped a step there. So we moved right 3, up 1. We can use these shifting patterns in a variety of ways because they apply to all types of functions. Recognizing shifts of other simpler functions can help us identify key features and compare them. One of the hardest things for students to grasp is the horizontal shift, which appears to work opposite. So remember, the shift on the x is opposite of what we would expect. Okay, so now this is talking about domain and range. So now right here, it's talking about the domain being from -3 to +10. Domain is your x, domain is your left and your right, okay? And then it talks about the range being y is greater than or equal to 22, and that's your up and down. Now you have this new function, okay? And we're going to, in your head, you're going to say that that is moving left 7, up 10. Okay, now the left 7 affects your x, which is your domain. The up 10 affects your y, which is your range. So I'm going to take the original domain that they gave me, which was -3 less than or equal to x less than or equal to 10, and I have to move this left 7 and this left 7. Okay? Anytime you're shifting to the left, it's subtraction. Anytime you're shifting to the right, you're going towards the positives, it's addition. So if you had to, you could draw a number line, and you would go, this would be -4, -5, -6, -7, -8, -9, -10. And look, that's a jump of 1, 2, 3, 4, 5, 6. That's 7 to the left. So that's like subtracting 7. So -3 minus 7 is -10. Okay? Same thing here. If you're at +10 and you go 7, you're going to be 9, 8, 7, 6, 5, 4, 3, and you just shifted 1, 2, 3, 4, 5, 6, 7. You went 7 left. Again, same thing as subtracting 7 from 10. So 10 minus 7 is 3. So this is my new domain on the new function. Oops, I can't spell. All right, for the range starts you at y is greater than or equal to 22. Now the shift wants us to go up 10. Okay, the shift here is up 10 to the y. So you're just going to add 10 to 22, and my new range is y is greater than or equal to 32. And that's my range. All right, example 4. Given the quadratic function, f of x equals x minus 4 quantity squared minus 5, answer the following questions. So one thing you guys should pay attention to is because it's squared right here, you guys know that this is a quadratic, which means you'll see a parabola on your graph. Okay, that's a quadratic. All right, and that shift that it wants you to make would be right 4 down 5, because it's opposite signs. So right 4 down 5. Okay. How has the parent quadratic been shifted to produce the graph of f of x? Well, I just said that. So right 4 down 5. Given that y equals f of x has a turning point at 0, 0, where must the new turning point be? Well, guess what, guys? It's +4, so the opposite side on your x, and then -5. That's my new vertex. Sketch f and give the domain interval for which it is increasing. Okay, so now, if I graph that, my vertex, as I just mentioned in part B, is at 4, -5. And then it keeps the normal pattern of any quadratic. Okay. So here's that graph right there. You can use your graphing calculator to help you as well produce those points, but it's the same pattern always. So that's my graph of y equals x minus 4 quantity squared minus 5. All right. Now it wants me to give the interval for which it is increasing. Okay. Well, the graph is going up from here over. So now I have to look at the x value where that's happening. So from +4 on, it is increasing. Okay, so from 4 to infinity, the graph is increasing. All right, part D, which has a lower minimum value, meaning the y value, the function f or the function absolute value of -6, close your absolute value minus 10. So this would shift the normal absolute value graph right 6 down 10, which means it has a vertex. That absolute value has a vertex of 6, -10. So -10 is lower than -5. So you know that the g function, this g function is going to have a lower minimum, okay? Because -10 is lower than -5. So f's vertex, which was the graph, was 4, -5. G's vertex was 6, -10. So the minimum value on the f function was -5. The minimum value on the g function was -10. So that's why the g is lower. Okay, last example here. The graph of f of x is shown below. The function of g of x is defined by. So this is only a shift right 2. Show that x equals -1 and x equal 2 are zeros for the function g. All right, so ready? Again, pick some definite points, and I'm going to move everything over right 2. So I move it over right 2, there's my new point. Here's another point up here, I move it over right 2. Here's a point here, I move it over right 2. Okay, so this will produce that first line there. Then at the origin it shifts over 2, and then down here it shifts over 2. So here's my graph right here, and that's the g function that I just graphed. I probably should have done it in another, okay? But it says show that those are the new x-intercepts right here. X equals -1 and x equals 2. So look, -1, +2, those are my new roots, my new zeros. Part B, evaluate each of the following using the definition of g. So I'm looking at the g only. So maybe I'll highlight my g in yellow, seeing I didn't do it in a different color. Okay, g of -3. So I go over to -3, and then I have to go all the way down, and that has a value at -1, 2, 3, 4, 5, -6. So remember, that's like a coordinate, -3, -6. At 0, my yellow graph is up at 3. And at 4, 1, 2, 3, 4, I'm down at -3.